today we'll be focusing on projectile motion in one dimension. Make sure that you hit the subscribe button and the notification bell so that you'll be notified every time I post a video. Now let's start here. Let's read the statement together. A ball A is thrown vertically upward from a height h with a speed of 15 meters per second. At the same instant, a second identical ball B is dropped from the same height. Please, I want you to note that they are coming from the same height, these two balls, as ball A, as shown in the diagram below. Now, in order for you to be able to to answer the following questions correctly, you need to analyze the diagram. Okay, so here we've got two balls here that they are coming from the same height. We've got ball A and ball B, and ball A here is going up, vertical upwards, and ball B is being dropped from the same height, but ball B is going down. Okay, so now here let's first analyze about ball A. So ball A will be going up, okay, and up to this height here. So ball A is going to reach its maximum height over here. So, and I want you to take a note that the initial velocity of ball A is 15 meters per second. But when ball A reaches the maximum height here, the final velocity will become 0. Because every time when the object is going up, so the gravitational acceleration acts on it and pulls the object downwards. So that's why the object will go up, and then when it reaches the maximum height, and then before it turns, so the VF's speed, it has to be 0. And then it turns back to the original position where it was thrown. Now, what else do we know about ball A here? We know the initial velocity here, which is 15. We know the final velocity, but we do not know the height here. So delta y we don't know here, and also the time delta t we don't know here. And what we know is that g, it is 9.8 meters per second. That one we know. Okay, now this is the information that we have about ball A from this position up to its maximum height. Okay, so that is the information that we have for now for ball A. Now, let's begin to answer the first question so that we're gonna hear from the question, what else do we need to analyze from the diagram. Now, in the first question here, so that is 3.1, they say explain the term free fall. What is the meaning of the word free fall, or the meaning of the term free fall? So free fall means an object. It means an object moving or motion under the influence of gravity or weight. So it's whereby when you are throwing an object vertical upwards, or maybe vertical downwards, but as long as the object is on air, so that at that moment, so we're saying that that object is on free fall, because that's where the force of gravity is acting upon that object. This is the definition for the term free fall: an object moving or motion under the influence of gravity or weight or gravitational force only. That's when only the gravity or weight or gravitational force is acting on that object, whether it's going up or down. So we say on that object it is what is on free fall. Now let's go to 3.2. Calculate the time it takes for ball A to return to its starting point. So I want you to take a note of that if now the time ball A is going to take from this position up to the maximum height, which is delta t up, delta t up is equal to delta t down. So from this position back to the same position. And also I want to take a note of that delta y up is equal to the delta y down. So this case it's only apply if the object is being thrown from this position and back to the same position. So we're saying that the height from here going up will be the same here. So in fact that means we're going to say the height at point 8 must be 0 because it is a starting point. All right, so that means the t up is going to be t down. So what else do we need to do here is to calculate the time from the point where ball A was thrown from here up to the maximum height. Now we can get the time from here up to this point because we do have the initial velocity and the final velocity, and then 9.8 also it is constant. So that means we can find the time just from this position here up to this part, just the time it takes from here up to this point here. So knowing that, once they say here the time to return its position or starting point, so that means the time that we're going to get from this point here up to here, then we're going to add that time by 2, or maybe we multiply by 2. We say this time here is the same from the maximum point up to the position where ball A was thrown. So the time up is the same as time down. Time up is equal to t down. All right, so I want to write down first the equation of motion over here so that we're going to select the one that is suitable for that particular question. So allow me to copy down these equations here. That is, the first one says Vf is equal to Vi. Okay, so these are the equations of motions, 4 of them, 1, 2, 3, 4. So we're going to choose the one that we think it is more suitable for that information or for that particular question. So by looking at these 4 equations here of motion, so we cannot use the second one. Why? Because the second one they would like us to substitute with the height here from this point up to the maximum, unfortunately. So we do not have the height from here up to this point, so that means we cannot use this the second one as well as the third one as well as the fourth one, because 3 of them they require the height. So that means now we are going to choose the first one. So firstly we need to choose the direction. Remember, ball A is going up, so we can also choose upwards as positive. Okay, that's sweet. Then I always advise my students to write the data here, just to collect the information that has been given here. So you just write over here data, and then you collect all the information. In fact, this is the information that I've already analyzed over there. So you just copy that information over here. Here we go. So this is the information, just only from this point up to the maximum there. So our Vi is positive because the initial velocity is going up, so we have also chosen upwards upwards as positive. So and only 9.8 must be negative here, because the force of gravity is always going down and we have chosen upwards as positive. So 9.8 goes against to this direction. All right, so we've already selected the correct equation, so I'm gonna just write it here. Vf must be plus a delta t, and then we substitute. So we set our initial velocity, so the final velocity must be 0, and then initial velocity is going to be 15, and then plus my 9.8, and then don't forget to put that minus there. Remember, we're looking for time going up, which is t up. So what we're gonna do is we're gonna just equate those ones. We're gonna just transpose this one. It is negative. When we transpose, change the sign, become positive 9.8 delta t, and on the side we just drop 15, and then we just divide both sides by 9.8 and 9.8. So this will nullify, therefore delta t must be equal to so we need to work this one out. So we can just select our calculator. We can just take our calculator here. All right, so we've got 15 divided by 9.8, which is 1,53. So this is our answer. So it is 9,53. So that is 1,53 seconds. This is the time from here up to the maximum. But now if you want to get the time from this point to the maximum, again from maximum back to its original position, we're going to just multiply this time by 2. That is, we're going to say times 2 here, because we want to get the return. So that means finally it should be 3,06 seconds. Let's just confirm that from our calculator here, that 1,53 times 2, so it is 3,06. Perfect. So that means this one is 100% correct. So this is the answer for the first question. Yeah, so let's move on to the second question. Now let's move on to the next question. So in 3.3 now they say here, calculate the distance between ball A and ball B when ball A is at its maximum height. Okay, so let's first clear everything here so that we're gonna see, because this information was only for ball A to get, just to get time. So let's just clear everything here. So we're gonna just yeah, I think now, yeah, it's clear. And then so yeah, what they are asking here is that when they say calculate the distance between A and B, remember ball A here, ball A was going up, right? And at the time ball A is going up, ball B is going down. Okay, so that means ball B is traveling this portion to the ground, while ball A is traveling that portion to its maximum height. So now if you want to get the distance between, so that means here we want to find the distance from ball B going down and the distance from ball A going up. Okay, so that means here we need to get the height here up from here up to this point, and from here up to this point. Okay, to get this height here we'll be using information about ball A, and then from this point to the ground, information about ball B. And then after that we simply say, therefore the maximum height or the maximum distance from the ground up to the highest point there, we're gonna just say that distance plus this one here, this one plus this one, and then we get the total. That is h up there plus the h down here, and then we just get the total. See, as simple as that. Okay, all right, so that is h and h. All right, so now let's begin to get the height first. About for ball A, we can just use the second equation, because we do have the initial velocity. Remember, I said it is vf, there is 0, and vi, it is 15. So we're looking for delta y here. All right, so that means here over in this question, so what I want to do here is that, so in 3.3, so we remember the direction is still the same. I don't want to erase this because we might need maybe time in the next question for 3.3. All right, so let's just I'm still having a space here, 3.3. so let's use the second equation. I don't want to repeat the data because it is the same. All right, so plus 2a delta y, so we simply substitute, so therefore the final velocity is naught, and then remember the initial velocity is 15 squared plus 2 times negative 9.8, and then delta y. So maybe I can say here delta y a, yeah, that's one, and then we just work this one out. So it's gonna be negative 2 times, must be 2 times 9.8, which is negative 19.6, and we just transpose this answer here. So that means we're going to get that is 19.6 delta ya is equal to the 15 squared must be 225. We just divide both sides by 19.6, therefore delta y of a must be the height must be 11.48 meters. So this height here that we've just got, this is height for ball A. All right, so then now let's go straight to ball B. So I said, remember I said here, what we're gonna do is that we are going to now we've got a height here, so the height here it is 11.48 from here up to this point. All right, and then now to get the height from here up to the ground, remember the statement said the same height as ball A, and remember ball A was traveling with 15 meters per second. At the same instant, a second identical ball B is dropped. So that means exactly at the time from ball A, that ball A took from the highest point to this point, which is 1.53 seconds. That time when ball A reaches here, and then it's the same time ball A was dropped. So that means ball A leave this part, this position here in what, in 1.53 seconds. And then we don't know the height for ball B. This is what we want to know, and we do know the 9.8 of this in this position here, and we don't know in fact the time. We do have the time here, so we want to know the height. So remember, we only know the initial velocity, which is 0. We don't know the final velocity. Definitely it is not 0. All right, so that means we cannot choose the first one and the second, because two of them, they require a final velocity, which we do not have at this point in time. So that means our option is the third one, is to choose the third one, the one that has only the initial velocity. So we're going to choose this one. In the place of vi, we put v, which is 0. In the place of a, we put 9.8, and we're looking for height. In the place of delta t, we put 1.53. Okay, so now let's begin, and we substitute here in this equation in 3 point. So just below this one, I'm gonna just write by saying and then for ball B, all right, so the formula here says delta y is equal to vi delta t plus half a delta t squared. All right, and then so what is going to happen is that we're going to say for delta yb is equal to the initial velocity 0, and then delta t must be plus half. And then don't forget that we've chosen direction as upwards, therefore 9.8 is going to be negative. What will be the time here? It's the same time. All right, so everything here times 0 is going to be 0, so we just work out on that side. So we're going to get 11 comma must be negative 11,47 meters, but the height we cannot leave the height as negative, so it must be positive 11,47 meters. All right, this is now this height. This is 11,47. this is the height from this point here up to this part, which is 11,47. Remember, here we've just got 11,48. this is 11,47, so that is 11,47 here. So this part 11,7 plus 11,48, then we just get the total. All right, this is what we require to calculate. So here we simply add the two ones, then we say therefore the distance is equal to must be delta y of a plus delta y of b, and then we just add the two ones, 11.48 plus 11.47. remember, we're not going to put negative here because that negative only indicates the direction, and the distance will never be negative, so therefore the height must be 22.95 meters. All right, so that is the question 3. Okay, now let's move on to the last question. Now in the last question here they say sketch a velocity time graph in the answer book for the motion of ball A from the time it is projected until it hits the ground. So now they're just asking us to draw the graph for ball A, only for ball A, not for ball B. Okay, so now in our graph we are asked to show the following, that is the initial velocity and also the time it takes to reach its maximum height. Remember, it is that 1,53, the maximum height, and the time it takes to return to its starting point. Remember, the time to return to its starting point, we've just got 3.06 seconds. So therefore we need to indicate this time. So therefore the initial velocity, remember, it's 15. All right, so we need to indicate the 3 ones, right? Okay, now let's begin to draw the graph. Let me just try to clear here because it's kind of date here, but I'm not going to need anything from here. We're gonna just draw the graph and showing these 3 points here that I've just highlighted. Okay, so I don't, so even if maybe we can just leave this part here. All right, that is 3.4. now let's go and sketch the graph. That is 3.4. so now to sketch the graph here, so right, and then let me just begin here. Perfect. All right, now we need to show the initial velocity. Remember, the graph of velocity graph versus time, it's gonna give you acceleration. Now remember, we have chosen our direction, we have chosen upwards as positive. So that means if we have chosen upwards as positive, our acceleration, it is negative. So our acceleration is negative. So if acceleration is negative, this one represents the gradient, so that means it's gonna have this shape here. All right, if this one is negative due to our direction. So I'm gonna put 15 here, the initial velocity, and then definitely negative 15 here, and this one must be 0. This is the graph of velocity meters per second, right? There's a mark for this. Just scroll around brackets, and then over here must be a time in seconds. All right, so then you also throw the arrows here as well. And then now in time in 15s, so remember the time at maximum, so the time at maximum is going to be over here. So I'm going to show that time here, that 1,53 over here, and then to return to its original position, 3.06 will be shown over here. All right, so now to draw the motion here, that means we're gonna just take it from the initial and passing through there and going straight to, yes, all right, that's perfect. So must be aligned with you see the final velocity as well as the time. All right, so this is the final, so the same velocity. All right, as for future purposes, so this point here, so this one, it represents the turning, so it represents the turning point. All right, or maximum. All right, just for future purposes. All right, so this is the question now. This is the question. Thank you so much.